Good morning friends, welcome back to Parnika tutorials. In the last video, I have discussed about the process state diagram and number of states in a process state diagram, what is the purpose of each state and what are the different types of schedulers are there such as long-term scheduler, short-term scheduler, medium-term scheduler. All these concepts I have discussed in detail for you. I hope you have watched that video. If you did not watch it, I request you to go back and watch the video and come back this video. In this video, I want to discuss about what is the need for a scheduling algorithm, what are the objectives of any scheduling algorithm, what are the various categories of scheduling algorithm. All these concepts I will discuss in detail for you. So I request everyone to watch the complete video for better understanding. First, let me discuss what is the need for a scheduling algorithm. To discuss that one, I need to draw all the states in a process state diagram. Totally we have 7 states. They are new, ready, running, terminated, wait, suspended wait, and then suspended ready. These are the 7 states will be there in a process state diagram. Okay. Now, when a process is ready to execute, it will arrive from the new state to the ready state. The long-term scheduler will do the task. Okay. In a ready state or a ready queue, we can have more than one process at a time. Is it clear? The degree of multi-program depends on the length of the queue. Is it clear? Are you able to understand? Now, let's assume that you have process P1, process P2, process P3 are there in the ready queue. Then one of the process, let's assume that you have only one processor. If you have only one processor, only one process can be there in the running state at any particular instant of time, maximum. If it is 0, then we'll say that CPU is idle. Is it clear? So the short-term scheduler has to dispatch one of the processor from the ready queue to the running state. Now, which one you need to schedule or dispatch? Either you have to do P1, you have to do P2, you have to do P3. Some criteria you have to take. That criteria will be depend on the scheduling algorithm what you are using. If you are using first come first serve scheduling algorithm, then you will need to look at the arrival time of all the process when the process have arrived to the ready state or ready queue. So which process has arrived first, then that process will be dispatched to the running state. If it is shortest job first scheduling algorithm, then you will look at the burst time of all the process. Which process has the less burst time, that process will be dispatched. If it is highest response ratio next scheduling algorithm, you will look at the response ratio of each process. The process which has the highest response ratio will be dispatched to the running state. So the purpose of a scheduling algorithm is to take one process from the ready state and dispatch to the running state. Let's assume that process P1 is executing its task. Now process P1 needs to do some IO operation. It want to read some information from the file or it need to write some information on the file. Then it has to interact with the IO devices. So if any process needs for the IO request, then what it has to do? The process will be sent to the wait state because always the IO operations will take more time as compared to the CPU execution. If let's assume that process P1 has gone to the IO request, if CPU is not executing any other process, then CPU is idle. So what it will do is that the CPU will send the process P1 from running state to the wait state. Then the scheduling algorithm has to dispatch another process which is there in the ready state so that that process will be executed. Once the IO request is completed, it will go back to the ready state. Is it clear? Similarly, if your wait queue or the wait state is full, still that some process needs the IO request, then it will be suspended to the suspend state. If it is free, then it will be resumed. Is it clear? Let's take that in ready state, your ready queue is full. Still a high priority process has arrived. Then you cannot deny the high priority process. Then what you will do is that as your queue is full, because the ready state will be there in the main memory. So if the ready state is full or the ready queue is full, you cannot deny the high priority process. You will suspend to that process to the suspend ready state. If the ready queue is free, then you will resume it. Is it clear? From the suspended wait also it can directly go to the suspended ready. Once the process has completed its task, it will go to the terminated state. Whatever the resources has been allocated, all the resources will be deallocated. So purpose of the scheduling algorithm is to schedule or dispatch one of the process from the ready queue to the running state. Is it clear? Now we will discuss about what are the objectives of any scheduling algorithm. One is that maximum CPU utilization. This is very important. Is it clear? You should not make the CPU idle. Any scheduling algorithm first objective is it has to utilize the CPU properly. And another important thing is that it has to minimize the turnaround time. Okay, and similarly, meaning is the turnaround time means average turnaround time. And then it has to minimize the average waiting time. Is it clear? And even it has to maximize the throughput. Okay, so all these are the objectives of any scheduling algorithm. Maximum CPU utilization is you should not make the CPU idle. Look at here, when the process P1 was running, okay, it needs the IO request. Then the running state is not, if you keep it like the process P1 in the running state, then the CPU will not do any other task. Then what you have to do? You have to transfer the process P1 from the running state to the wait state. You request the IO operations in this state. Once it is complete, you go back to the ready state. In the meantime, the scheduling algorithm will dispatch another process which is there in the ready state and it will complete its task. I hope it is clear for you. Similarly, you have to minimize the average turnaround time. What is a turnaround time? Turnaround time is completion time minus arrival time. You have to minimize the average turnaround time of all the process. Similarly, you have to minimize the average waiting time. What is a waiting time? It is turnaround time minus burst time. So you have to reduce as much as possible the waiting time of all the process. Okay, and you have to increase the throughput. So these are the objectives of any scheduling algorithm. Okay, now let me discuss about the categories of scheduling algorithm. Broadly, the scheduling algorithms are classified into two types. One is non-preemptive scheduling algorithms and another one is preemptive scheduling algorithms. Non-preemptive, another category is preemptive scheduling algorithm. Now let me discuss what is meant by non-preemptive scheduling algorithm. Then I will discuss about the preemptive scheduling algorithm. Let's assume that if some process, let's take the process P1, process P2, process P3 are there in the ready state. Based on some criteria, whatever the algorithm you are using, based on some criteria, let's take that process P1 has been dispatched to the running state. Now if it is a non-preemptive scheduling algorithm, if process P1 needs 3 units of CPU time to complete its task, if it is non-preemptive scheduling algorithm, the entire 3 units of time will be given to the process P1 unless until it requires the IO burst time also. Let's assume that the process P1 only needs the CPU utilization time. Then the process P1 will execute for 3 units of time. Once it is completed, it will go to the terminated state. Meaning is that when the process P1 is executing its task, none of the other process or the scheduling algorithm will not disturb this one. When it comes to the preemptive scheduling algorithm, okay, if you have ready state and running state, let's take that process P1, process P2, process P3 are there. Based on some criteria, process P1 has been dispatched to the running state. It needs 3 units of time. Now, what is preemptive scheduling algorithm is? To discuss about that one, let me discuss time quantum. Meaning is that if you are using a round robin scheduling algorithm, they will give a terminology called time quantum. If the process P1 needs 3 units of time or if it needs 5 units of time, it can run only 2 units of time. Once it is completed 2 units of time, then it will be sent to the ready queue, and the process which is there in the ready queue will be sent to the running state. Is it clear? Or similarly, let's take that a high priority process came. Suppose let's take that burst time is the criteria. If you're taking the shortest remaining time scheduling algorithm, which is a preemptive scheduling algorithm, suppose let's take that process P1 needs 3 units of time. By the time process P2, process P4 have the remaining burst time 1 and 2, they are in the ready state. Now, if process P1 needs 3 units of time, there are other high priority process, meaning is that if you're taking the shortest remaining time scheduling algorithm, the process which has the less burst time will be given high priority. Then P4 has the highest priority as compared to P1. So you will do the context switching. Process P1 will be sent to ready queue, process P4 will be sent to the running state. So without completing its task, if high priority process have came or the time quantum is completed, that process will be removed from the running state and will be sent to the ready state. So this is the difference between a non-preemptive scheduling algorithm and preemptive scheduling algorithm. Let me give few examples related to the non-preemptive scheduling algorithm. Then I will give examples for preemptive scheduling algorithm. The first non-preemptive scheduling algorithm is first come first serve scheduling algorithm. And then the next scheduling algorithm which is non-preemptive is shortest job first scheduling algorithm. Similarly, you have longest job first scheduling algorithm, and then you have highest response ratio next scheduling algorithm. These are the examples for non-preemptive scheduling algorithm. Then what are the examples for the preemptive scheduling algorithm is shortest remaining time first scheduling algorithm. Similarly, longest remaining time first scheduling algorithm. Then you have round robin scheduling algorithm. These are the examples for preemptive scheduling algorithm, and these are the examples for a non-preemptive scheduling algorithm. Remember one thing, any scheduling algorithm will have two important parameters. One is the criteria and another one is mode. What is meant by first come first serve scheduling algorithm is, if you have multiple processes which are there in the ready state, which process you need to dispatch to the running state. If it is first come first serve scheduling algorithm, the process which has arrived first will be given high priority to dispatch to the running state. So that is what we will call it as a criteria. And mode is whether the scheduling algorithm is non-preemptive or preemptive. Then similarly we will have another one, tie. Suppose let's take that multiple processes are there in the ready state and all the processes arrived at the same time. Then there will be tie in the arrival time. Then how you will resolve it, which process you will give the highest priority. Then you will look at the process ID. The process which has the lowest ID will be given priority to dispatch to the running state. So all these scheduling algorithms I will discuss in the coming videos. I hope you have understood the need for a scheduling algorithm, objectives of any scheduling algorithm, and categories of scheduling algorithm. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.